Hi, welcome back to page 2 of your review for Unit 10. Number 4, find the surface area of the composite figure shown below. So when it says to find the surface area, that's all, when you have a composite figure, it's all the outside parts of this figure. So I can see I have a cone, and then I can see I have half of a sphere, or a hemisphere, you could call it. That would be a better thing to call it, but the formula we're going to use will be half of the sphere. Now for my cone, I have two areas. I have lateral area and I have surface area. And I can tell on this one, since it's not going to be this inside part, I'm not going to be using the base of that cone. It's just the lateral area is all I want for that cone. And then for a sphere only has one surface area. But when you cut it in half and make it a hemisphere, you do have a lateral and a total surface area, because sometimes we need to add that bottom on. But again, the bottom of that hemisphere is inside my shape, so it wouldn't be considered part of the surface area. So it really is just going to be 1/2 of the sphere. I'm not going to add on the extra base. Okay, so let's look at my formula chart and remind ourselves what 1/2 of what the lateral area of the cone is. So my lateral area of my cone, remember lateral area is your first column, even though there's S's, we normally use L's. And then we want cone, so my lateral area is pi RL. So I'm going to use pi RL. And then for my sphere, 1/2 the sphere, if I look at the sphere formula, my sphere is, for my area, 4 pi r squared. So I know half of 4 is going to be 2 pi r squared. Okay, so when I fill this in, pi r, my radius is 8, and then my slant height. They gave me my regular height. They didn't give me the slanted height. So I have to compute that. Remember, your height is always going to be perpendicular to your radius or your base. And then, so my slant height comes from this little right triangle, where this is a hypotenuse because it's across from the right angle. So inside my square root, I'm going to want to add, and I'm going to use 19 and 8. And so I'm going to end up with, let me grab my calculator, I'm going to do 19 squared plus 8 squared. That's going to be the square root of 425. So the square root of 425 is this ugly decimal. And I don't want to do any rounding to the very end, so I'm just going to leave it for now as the square root of 425. Okay, and then my sphere over here, 2 pi r, my radius is 8 squared. All right, so this one, if I rewrite it just so it looks mathematically normal, the way we write things, we normally put numbers in the front, plain numbers in the front, and then we put any variables. If I had an x or a 7 or a 2 would go next, but I don't, or an x or a y or a z. But now I'm going to use my pi, and then my square roots will always go last, 425, which that is probably reducible, but for now I'm not going to really worry about it. And then I'm adding that to 2 pi 8 squared. So I'm going to do 2 times 8 squared without the pi. And when I do that, I get 128 pi. Okay, now normally we'd be able to add these together because they both have pi's, and I'd be able to get an answer that was simplified, an exact answer. But this is going to be as close as I'm going to get to an exact answer, because since this one has a square root and this one doesn't, we can't consider them to be like terms and add them together. So this is really kind of my exact answer. I'm going to go ahead and put the whole thing in my calculator to get an approximate answer. So I'm going to do 8 times pi times the square root of 425. Notice the square root bar is still over my cursor, so I'm going to arrow out of that when I do my plus sign for in between my two expressions. So I have 8 pi square root of 425 plus 128 times pi. 128 times pi. Okay, so I have 8 times pi times the square root of 425 plus 128 times pi. This is going to give me my approximate surface area, which is 920.24. I'm going to round that up because of the 5. 249. 249. I don't have any units here, so I'm just going to say units. And since it is area, I'm going to put a square on the units. Okay, let's look at number 5. Find the area of the figure below. So again, I'm still working with area, and this time I have two-dimensional shapes. So I have a parallelogram and I have a triangle. So I just need to find the area of the parallelogram and the area of the triangle. Oops. The triangle, I was going to draw it instead of write it. And then I'm just going to add them together. Okay, so my parallelogram, I remember, is base times height. Remember, if you forgot, you can go look at your formula chart. My triangle is 1/2 the base times the height. And again, you have your formula chart if you forget those formulas. And we're going to be adding these together. Now, remember, when you look at each one, you have to use this formula for the shape that it belongs to. So for my parallelogram, its base and its height have to come together at a 90-degree angle. Okay, so I can see the base is 18, the height is 12. And then my triangle, 1/2, the triangle's base times the triangle's height. Now again, your base and your height have to come together at a 90-degree angle. So I have to think of this triangle as being on its side, and the base and the height will be the 18 and the 11. And it doesn't matter which one you call which, because you could think of this as the bottom of the triangle and just rotate the whole triangle 90 degrees. Or you could think of this, flip the triangle over, and think of this as the base. Okay, so it doesn't matter if we say the 11 is the base or the 18 is the base, because really we're just multiplying them together. Okay, all right, so my parallelogram, 18 times 12. And my triangle, 1/2, 11 times 18. 1/2, 11 times 18 is 99. When we add the two together, 216 plus 99, we get 315. And this is area, and I do have units. My units are feet, so they are square feet. Okay, let's look at number 6. All right, for number 6, 2 square pyramids are similar. Ooh, that's a good word to note. 2 square pyramids are similar. You know what that makes me want to do? The sides of the bases are 10 and 15 inches. So I have two, actually, I'm going to do it. I'm going to try to draw them a little bit nicely. 2 square pyramids. Remember, when you draw the base, part of it's not going to look like a square because you're standing in front of it. So it makes the base look a little more like a rhombus. I come straight up from that back corner, and then I come down to the other corners. Ooh, my pyramid's a little squiggly. Okay, so one has a side base of 10 and the other is 15. So the other is a little bit bigger. Straight up from that back corner and then straight down to the other corners. And it has a side lengths of 15, and they're squares. So it's 10 by 10 by 10 by 10 and 15 by 15 by 15 by 15. The height of the smaller pyramid is 9. So height, remember, is your chandelier height. It comes straight down and hits the center, and that is 9. They didn't give me the height of my larger pyramid. I don't know if I need it. It wants me to find the volume of the larger pyramid. I don't have any volumes, but what I do have is I have a side that's 10 and a side that's 15. The first thing I want to do when I'm setting up my SPAV table is I want to remind myself one pyramid is always going to go in the numerator. The other pyramid I'm always going to put in the denominator. It doesn't matter which you put where, as long as you stay consistent. So I'm going to put everything from the small pyramid on the top and everything from the big pyramid on the bottom. So when I come to fill in for my 10 and my 15, because those are matching pieces, it's the only matching piece I have, those are side lengths, which means I can either put them under S for side length or I can put them under P for part. Either one, however you want to think of that. So if I put them under S for side, I would do 10 over 15, and then that would reduce to 2/3. So I know the ratio of the parts is 2/3. So the ratio of the heights, the ratio of the slant height, the ratio of the altitudes, which is the height, okay, are all 2/3. My areas are going to be squared. So 2 squared is 4 and 3 squared is 9. My volume is going to be cubed. So 2 to the third power is 8. And 3 to the third power is 27. Okay? Find the volume of the larger pyramid. All right, I don't have any volumes at all. If I look at my formula chart, to find volume of a pyramid, I have to do 1/3 the area of the base times the height. So if I look, I can find the area of the base for each pyramid, and I know the height for my small one, so I can find my small volume. I don't have enough information to find my large volume. So I have 2 ways I could do this. I can either find the height of the large pyramid and then use my parts ratio and set up height to height. And then once I find the height, then I'll still have to find the volume of this, okay? Or I could find the volume of the small pyramid and then use that and the volume proportion to find the large volume. I think that's what I want to do. I'm going to find the volume of the small pyramid. So the volume is 1/3 the area of the base times the height. Now my base is this square. My base is 10 by 10. So my base here is 10 times 10 because it's a square. So my base is 100. And my height is 9. So the volume of the small pyramid is, oops, I wanted to grab my calculator, 1/3 times 100 times 9. And that gives me 300. And again, that is for my small one. And I'm trying to find out what is my large volume. I know my volume should reduce to 8 over 27. 8 is smaller than 27 because my small is on top, right? And my big is on the bottom. My small volume is 300. I want to know, what is my big volume going to be? This just needs to be cross multiplied. When I cross multiply, I'm going to get 8 times x and 300 times 27, which is 8,100. And then I'm going to divide by 8. And that gives me x equals 1,012.5. Okay. Again, my other option would have been, I could have said, well, 9 to this height. 9 to this height has to reduce to 2/3. So I could have done that. I could have done 9 to h equals 2/3 and cross multiplied. Oops, 9 times 3 is 27. So my h, when I divide by 2, 27 divided by 2 would give me 13.5. And then I could have said, okay, 1/3 times the area of this base, 15 times 15, times the height, we just said is 13.5, gives me, oh, look, the exact same volume. So again, either way, you could have either found the height using the 2/3 for parts and then found the volume of this one, or we found the volume of this one and then used my volume ratio. So either way, you're using a ratio to find something, but you have to find something else either before or after that. You have to find one of the volumes before or after you apply the ratio. Okay? All right, I'm going to erase this so we don't get confused when we go back and look and say, how did I get from here to there? All right, so in the next video, we're going to look at page 3 of your review. If you have any questions on page 2, make sure you're asking during sync time or live and in person. Thanks for watching.